Good morning. My name is Jacob Velky. I'm the manager of unmanned aerial systems for Duke Energy. We're a large utility based out of Charlotte, North Carolina, and have been utilizing drones since really late 2014. So you've kind of heard an overview of drone technology. You've heard from maybe more of the regulatory side. So think of me as more of kind of the end user owner of a large asset intensive organization that's leveraging the value of the drones that you've heard about this morning. Quickly, just a little bit of background on Duke Energy in case you haven't heard of us. So, like I mentioned, based out of Charlotte, North Carolina, 7.7 million electric customers across 6 states, with another 1.6 million gas customers in 5 states, with a commercial renewable portfolio really coast to coast. So, wind and solar, really from New York to California. And so where this is really important is because all of this feeds why drones are important to Duke Energy. When we think about the business that we're in, there's a ton of ways to get injured, whether it's working around energized equipment, working at heights, working in confined spaces, along our right-of-ways in Florida, where there could be alligators and snakes, whether it's in Ohio right now in the middle of winter, using the drone to go and inspect something to reduce the amount of time our employees have to spend in that hazardous environment so that everybody at the end of the day can go back to their families the same way they showed up to work in the morning. Also, we have to know a lot about our assets. So using the drone to collect data, to know as much as we can about the health of our assets, to make more predictive decisions as opposed to running things to failure and then have to replace. And then the drones are also providing for us an opportunity to get just more information than we've had previously about those assets, to really think more strategically about how we're leveraging them. I'm going to talk to you a little bit this morning about our journey of transformation with the drones. A lot of hype around this technology. I think Jeff Bezos was on 60 Minutes 5+ years ago saying that your razor blades were going to be delivered to your doorstep any day now. Still hasn't happened. Maybe it will get there at some point, but really tempering that hype, that excitement of the technology with what's practical at this point, and then charting a road forward for what may be possible in the future. So as I think about the hurdles that we've had to overcome over the last 5 years, we've been working with the technology. I would really bundle them into these 3 main components: regulations, technology, and people. And so quite often we hear the FAA is the one holding up the process for integrating the technology. Well, that may be part of it, but it's also maybe the fact that we're widely using drones that are lithium battery powered in nature. And so they have a limited flight time. There are other technological limitations that are preventing us from, in our case, inspecting 32,000 miles of transmission line across those 6 states. And then there's that people component that we don't really talk about that often. People get stuck in their ways. So as I think about a company with 30,000 employees, linemen who have done a job a certain way for decades, getting them to embrace new technology and leverage it in a way that changes the way they've done it is a hurdle to adopting the technology. And so kind of the banner there, it's not quick and it's not easy. When I think that we've been using this technology since 2014, in a lot of ways, we've moved the needle forward. But when you think about it over that course of time, we really probably could be further ahead than we are. I'm going to actually go to the next slide and then come back to this. So we've heard a lot this morning about the FAA, so I'm not going to beat the dead horse. But 2 facts that haven't been stated this morning are the fact that the United States has some of the most densely populated airspace in the world. Fact 2 that goes along with that is the United States has some of the safest airspace in the world. So when we pair those 2 facts together and we think about the slow road the FAA has given us to putting rules and regulations in place for drones, that's really the basis for why that is. And so at Duke Energy, again, we're all about safety. We have helicopters flying right over our transmission lines conducting inspections today. Those helicopters have a minimum 2, most of the time 3 individuals on them. I want the FAA to be very sure that they have a safe process in place before there's widespread use of drones beyond visual line of sight, because I need that pilot and those 2 observers to be able to come home at the end of the day and not have to worry about ducking and dodging drones all the way. There are penalties associated with using drones inappropriately. Someone mentioned the Super Bowl. I did see one person was arrested for flying drones inappropriately. So as you think about if you're an end user of the technology, think about some of these liabilities associated with grabbing the technology. It's not as simple as just running down to Best Buy, buying a drone, taking it out in the field, and beginning to use it. So I'll back up. So we talked about these different buckets that the Assure program's building to talk about different training and those types of aspects. Really trying to go back and model it a lot like manned aviation. Am I done? I'm cut off. Uh, so if you're in manned aviation, there's different thresholds for certification. You have a private pilot certificate. You can fly a certain aircraft during certain meteorological conditions. As you go up over 12,500 pounds, you get a specific type rating specific to that aircraft. Well, right now, everything under 55 pounds is a written test. The dirty secret is the FAA doesn't even want to see you fly a drone to say you're a safe operator of the technology. And so again, as an owner operator of utility, if we're going to have our employees use the technology, we've got to go compliance plus. And so, yes, we'll give you the tools you need to pass the FAA written examination. But if you're going to use the technology as a Duke Energy employee, we need to be able to see you use the technology safely and make sure that the first time you're using the drone for a specific use case isn't when you're doing it around one of our active nuclear power plants. And so we've really set up a program at Duke that walks through that process to ensure that after the employee passes the examination and we give them their drone, we're going to feel confident that they have all the instruction they need to use that safely. And so today at Duke, we have about 100 drones across our fleet and about 140 employees throughout the company who are using this technology as another tool in their toolbox. I should also mention that in my position, I sit within our aviation organization. So I sit along our jet pilots, our helicopter pilots, our mechanics. And so for our Center of Excellence at Duke Energy, really trying to learn and embrace all the lessons learned from manned aviation so that we don't have to relearn all those things in unmanned aviation. And so whether, if you're going to use this technology, you have access to those resources, or consider maybe reaching out to consultants that you can tap in to that base of knowledge as you move your program forward. So how we're using it. I'm going to go through 3 or 4 just examples of how we're doing it. Because of some of the challenges with operating beyond visual line of sight, we really see the helicopter, which has been our primary method of doing long linear inspections, still being the most economical approach to doing those inspections today. But what that leaves us with is still a wide variety of use cases for drone technology. The first I'd really bucketize as vertical asset inspection. And so this is a hyperbolic cooling tower at our Crystal River plant over on the Gulf Coast of Florida. And so we were asked if the drone could be used to help with the cathodic protection inspection of this particular asset. And so in the past, what that would have meant is an individual would have had to climb up this tower, rappel off the 4 quadrants, and do this inspection of the cathodic protection on the cooling tower. With the drone, we were able to fly around the entire asset. So that's the picture on the right with the blue-green dots. Take 4,000 images and then bring those images back to create a 3D model, which is on the left-hand side, and complete what we would refer to as a desktop inspection, keeping all the boots on the ground. And so leveraging that 3D model in Pix4D is the software that we use. We're able to go anywhere on that 3D model. For this example, I've selected the catwalk on the top of the cooling tower. And so the software is going to go through all 4,000 of those pictures and say, where does that catwalk show up in the imagery? And so it's a little bit hard to see, but down here in the corner, the software is telling us there's 73 pictures of that particular instance in all the imagery. And so if I'm doing an inspection of that catwalk, I can use those images to take more of a top-down look, a bottom-up look, left to right, and really get as much information about the integrity of that asset from pictures as if I had climbed up and rappelled down the side of that asset. So it's a huge time savings. It's a huge safety multiplier. And in a lot of cases, you're getting more information about this asset because we've got now the full 360-degree look of that asset as if we had rappelled off 4 quadrants. We can take the same approach internally. One of the little insider tips and tricks too is if you're flying a drone inside, the FAA doesn't have purview there. So this is a great opportunity to test technology in an instance where the regulatory hurdle isn't there. So for us, inside of our boilers and tanks and things like this, it's a great opportunity to push drone technology. So taking that same methodology, we looked at the cooling tower. This is a burner wall inside one of our coal fire plants. Instead of having to completely create a confined space, a safe area for an individual to go in, build costly scaffolding to access these areas of our confined space, we can now open the hatch, toss the drone in, and the drone can get all the information about the integrity as if we were to go through all those steps. In this instance, we're able to kind of go a little bit further than the previous example. So now we're clicked on one of the burner cans of the boiler wall, and we can see that there's 33 images of that particular burner can. Now we've flipped from point cloud, 3D model point cloud, to the high resolution image, and zooming in, we can see with very great clarity the health of that asset and make a determination. Is everything good to go? If so, let's get the plant back up online, generating electricity. If not, then we now have a plan of attack as we build scaffolding for the parts and tools that we'll need to go and fix this. Again, with the goal of getting the plant up and running faster than if we hadn't been able to lay eyes on it until we built the scaffolding. Solar inspections were mentioned in the introduction this morning. So I'm based out of Charlotte, North Carolina. Currently, North Carolina is number 2 in the nation for installed solar capacity. I know they're building like crazy here in Florida, so we'll hold on to that while we can. But what that means is there's a tremendous amount of solar assets that have to be inspected over a period of time. The previous method of inspection for this was a 2-person team in full protective gear walking around the solar field and going up to combiner boxes to see if the associated output of the panels compared to the engineered value of what those panels were supposed to produce. And if there was a delta, tracing the lines back to the panels to figure out where the issue was. Flying the drone with a thermal camera, you're able to see the difference in the heat of the associated panels. And you quickly began to see issues like this: multi-panel faults, single cell faults, and half panel faults. Behind each of these images is a wide array of metadata, the most important being precise latitude and longitude of where that particular fault is in a solar field. So if we think about a 500-acre solar field where all the panels look the same, I could take these 3 images right now and put them into Google Earth, and they would lay on the panels in 3 different solar fields in North Carolina, and the tech would have no problem knowing where to go to fix those panels. But the problem with all this, we talked about a little bit this morning, is just a tremendous amount of data. Cybersecurity being on the minds of everybody, I can't plug a USB into my laptop at Duke Energy because we're worried about cybersecurity. So really thinking before we build out all these use cases for drones, how are we going to do data management? How are we going to get the data from the collection device onto our network? What AI exists, or what AI can we build to distill that information into something that's going to be actionable? Because what we found early on with use cases like this, it's easy to train people, it's easy to buy the drones, it's easy to collect the data, but this data was dying in SharePoints and shared drives. No one was actually taking the time to go through and generate those work orders. And so you've got to be careful that you're investing in all this technology, but if you're not actually making it useful and reaping the reward from it, then you're going to really have some executives questioning why you're using it at all. Storm damage has been huge. So here we are in Florida. Part of our regulated footprint is in Florida, also in the Carolinas. We have the joy of dealing with hurricanes every fall. And so using the drone as a force multiplier for our previous methods of storm damage assessment, ground-based, car-based, helicopter, has really been interesting to kind of watch that progress over the past several years. During Hurricane Florence, it was our biggest kind of lift, if you will. We had requests for 48 drone crews. We ended up deploying 43. And so one of the things we had to even coordinate internally is how do we know where all those drones are? Because we also had over a dozen helicopters in the same area. And it would be the worst case scenario if we had one of our drones and one of our helicopters end up in the same place at the same time. And so sometimes you don't need the most complicated solution. We went with Life 360. If you have kids, maybe your wife has it for you, but it's a free mobile application that tracks where your cell phone is. And so right now, flying within line of sight, we know that our drone's going to be next to our person who has a cell phone on the ground. And our helicopters are operating at an altitude that they have great cell service as well. And so this allowed us to enhance our situational awareness to know where all of our assets were at any given time. And then on a kind of a softer use case, the drone's a great storyteller. So for a utility, we're a regulated utility, regulated monopoly, we have to do this dance with our customers. And so part of doing that dance with our customers is letting them know, what it takes to keep the lights on. And so after a hurricane, using the drone to document what that damage is and getting it out on different social media channels to say, this is the challenge that we're up against. But then as we're bringing resources into the affected area, also documenting that to say, yes, your power's off, but we have 10,000 crews here today that are working on getting your power on. And so one of the things I like about this slide is this one video up in the top right was just of some down distribution lines. We got 500,000 views of that one video. And so while that's not Kim Kardashian, kind of likes and impressions, that's pretty impressive when you think about a utility posting a video of a down distribution line and how many customers are going out there and looking at that. It's kind of the same thing after Hurricane Michael, not using the drone to necessarily do anything other than to tell a story. And so we were able to use the drone to document the rebuild of a 34-mile transmission line that came down in the Panhandle. And it ended up being one of the most viewed videos our company has ever put out there. And so as we think about kind of adopting new technology, I'd love to go back to the operational excellence model. We do a lot of, we spend a lot of time planning our missions, training, trying to think about ways to mitigate risk, but never do we go out into the field and everything goes to plan. And so the key for us in this model is that check and adjust. What went right? Let's do more of that. What didn't go as planned? What can we do to try to mitigate that going more to the way we want it to go next time? And so our guys spend time doing a flight risk assessment before every flight, but they also spend time talking afterwards to do a debrief with a focus on this model. The last one I'll hit, we had a unique opportunity to go to Puerto Rico after Hurricane Maria. Drones was kind of an afterthought for the Duke Energy deployment down there in terms of restoration, but we were able to really kind of think about using drones as more than just a data collection device. And so one of the challenges for where Duke Energy was working was geography, topography that looked a lot like this, kind of mountainous areas, densely vegetated. And so it was a real challenge for getting power lines back up that had been knocked down after the storm. It was kind of hard to see where two wooden poles were in the middle of a forest, let alone have a right-of-way to lift the conductor back up. And so we were able to go down and take one of our larger drones. We had kind of thought through this use case before, but never really had a chance to utilize it. A team member of mine had 3D printed in his garage an electromagnet device that we could use to connect the drone with a spool of light line, paracord in this instance. And so with this combination of tools and technologies, we're able to go to situations like this, where Brian is standing in front of one distribution pole, and the other pole is 1,200 feet away on the other side of this valley, and take that light line to the other side that could then be attached to a woven nylon fiber that could be pulled back, and then ultimately the conductor for that line pulled back in. The only other way that they would have been able to do this is kind of hack their way through that vegetation, or with a helicopter. But in Puerto Rico, after Hurricane Maria, the helicopter just wasn't an option. And so again, kind of thinking outside the box, and again, going to where I started, all under the hurdles or constraints for which we're all operating today. This is completely within Part 107, the rules and regulations, with existing technology. And what was really awesome about this was both myself and Brian, a year prior to this, had been working in supply chain at Duke Energy. So we were doing RFPs, POs, and contracts. And so here we were able to bring a solution to Puerto Rico and work side by side with linemen who had done their job for decades and say, here, we have a method, an application that's going to help you do your job differently. And by the end of the week, we had a ton of believers. So some key takeaways, if I had to think about transformation, especially for drone technology, transformation takes understanding. We can't just assume that we know the best way to use the drone. You got to get out in the field. You got to talk with your folks and say, what are your challenges? What are the opportunities? And research where the drone can potentially fit that niche. It may be that the drone doesn't, and you default to some other existing technology, airplane, helicopter, other non-aviation resource. Communication is key to understanding. There's so often when you have new technology, people want to be the technology hero. They don't necessarily want to share that with anybody. You got to be open and communicate with your internal and your external stakeholders. And the transparency builds the trust needed for true transformation. So if you can't be honest and say, we thought we had an idea, turns out it's not going to work, and then you're not going to be able to build that trust with the folks that you need to kind of see it all the way through. So transparency is key to that. But if you're able to bring all those things together, then internal stakeholders and external stakeholders recognize it. And so this is just a smattering of some headlines and some different publications that I probably never figured that I'd be in, from Wired to Popular Mechanics to an interview on NPR. And so that's really exciting, especially to work at a utility that's kind of known as being a dinosaur when it comes to embracing new technology, to see that we can adopt this and change the way that the industry is going to do some things. So I appreciate the opportunity to share what Duke Energy is doing with drone technology, and hopefully we have a couple more minutes for questions.